All right, here we go. Multiplication of decimals. So as usual, when we model something new in math, we need to know a couple of things. What does multiplication mean and what is a decimal? So as far as our modeling for that goes, we have a couple options for multiplication. So either multiplication is interchangeable with the phrase groups of, and we can demonstrate what that means, or we can say multiplication is an area. An area is base times height. So we should be able to show a base and a height, and then from that come up with an answer. Based on how we model that, we should then be able to produce an algorithm where we don't draw pictures, we just get the job done. So then decimals are parts of a whole based on 10. So those base 10 blocks are what we're playing with to do this. And so we'll have to decide, well, what is a whole? So we always want to make it clear when we're modeling with these base 10 blocks, which block is a whole. And so we have to have that key to go with. And sometimes we switch it. And so we got to be clear with whoever we're working with that, hey, we switched. This is a whole now. So we'll get to that in a second. So we'll just start really simply here. And look at, say, 2/10 times, let's say, 4/10. And what does that look like? So again, a decimal is an equal part of a whole. And so I need to look at a whole. If I'm using an area, then a whole is a square. So area, remember, a whole is a square usually. Sometimes we used a hexagon before, but for often we use a square. And think about it, we measure in square feet, square meters, square centimeters, square miles. So then I'm going to try to draw that out here. So let's see, if I start here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 that way, because again, decimal is out of 10. And then this way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hopefully I didn't miscount that. We'll check in a second. So this right here is going to be my one whole. So I could say, like, from here, I'm going from 0 to 1, and let's just double count. If you don't have graph paper, then you'll need to, I would recommend a ruler. If you don't have a ruler, you can make a ruler. That's 5, 6, 7, 8, 9, 10. Yeah, I went right in that direction. Okay, so I've got my tenths in each direction. So if that's 1 right there, then let's say 0.2 would be right here. So I'll just shade that in. So this right here would be 2/10 of the whole. Now I want a region that's 2/10 by 4/10. So then I have to mark off 4/10 the other way. And again, I'm using this idea that multiplication is an area. So 1, 2, 3, 4. So then right here, if that's 1 up there, that would be 4/10. So let's use a different color for that. So there's 1/10, 2/10, 3/10, and 4/10. And I'm looking for the region that is 2/10 by 4/10. And so that would be this region right there, 2/10 wide, 4/10 tall. So there's my base of 2/10, my height of 4/10. So that's this thing right here. Now remember, this whole square is a hole. Big square is a hole. Someone just rang the bell. Let's go say hello. Sometimes Zoom doesn't like to show me. Montse is here. Hello and welcome. So if the big square is a whole, what part is this? Well, the big square as a whole is a 10 by 10 grid, so there's 100 little things in there, so those little things must be hundredths. And so I have 1, 2, 3, 4, 5, 6, 7, 8 of those hundredths. So 0.2 slang, 2/10 proper, times 4/10 is equal to 8 hundredths, according to my picture here. That makes sense? Questions on that one? Chat's quiet, I hear no voice. I take it we're good on that one. Okay, so I'm gonna switch over to my other camera. So I wanna show the actual toys. Oops, wrong button. Come on, Zoom. There you go. All right, so the base 10 blocks. So I've got this big giant cube here. And then the next piece down in size are these flat pieces. And if you stack up 10 of these flat pieces, it makes one of these big cubes here. This flat here is made up of 10 of these longs. So if I stack up 10 of these longs together, right, I can make this flat piece right there. And then I've got these little tiny cubes here, and 10 of those line up to build a long. I'll just put 5 there for now. So 5 units make half of a long, 10 units makes a whole long. 10 longs, right, that makes a whole flat, and 10 flats, that makes this whole giant cube. Now the giant cube is harder to work with on a computer screen, so we're just gonna throw that one out. Goodbye. So that means in our virtual days, because we need better software, we have to work with the flat, the long, and the unit. And so whenever we do that in a situation, we need to be clear which one is going to be the whole. Now here I'm talking about area. And so for area, I would prefer this thing right here to be one whole. And then on that, I can see those vertical strips in there, right? So just like it's made up of longs. Throw a long on top there. And in the example I was just doing, I was trying to show what does 2/10 by 4/10 look like, and that by means that they have to intersect. Another way to think about it is groups of. So imagine 4/10 of a group of 2/10. So this is a group of 2/10 right there, sitting on top. Right? I have 2 pieces, 10 of which make up a whole. And I want to end up with 4/10 of that group. Well, if I just focus on one of them and I throw 4 reds on top of there, come on, that one's not my please, there we go. Right, there's 4/10 of one of them, so I must need to do that again, take another 4, throw them on top. And again, there's a lot of evidence out there that kids that play with these toys, thinking about math, physically touching math stuff, helps kids get a better mathematical intuition that helps them later in life. So now with the red on top here, I'm showing what does 4/10 of a group of 2/10 look like. So let's see if I can slip out those guys, put that on top. And then we can explore that more with the kids. We say, okay, how many little squares are there in the whole thing? And they would remember, oh, there's 10 by 10, 10 times 10 is 100. So there's 8 out of 100, right? 8 out of 100, 8 hundredths. Now, we don't necessarily have these physical toys to play with because I don't have enough to send them out to everybody. And you can buy these, but the book tuition plus buying all these toys is too costly. So usually we share them in the classroom. Since we don't have the classroom, then we are forced to use these online versions of them. So let's play around with the online version. Just make a note about the other way I viewed this. Let's call this option 2, multiplication as groups of. So 2/10 times 4/10, and I actually wrote it back. I did it backwards when I was playing around. I was viewing it as 4/10 times 2/10, because when I built that, that little grid of red units, I was basically answering the question, what is 4/10 of a group of 2/10? And that led me to this region right here. Now we could certainly reverse that and use the top one. The top one says, what is 2/10, 2/10 of a group of 4/10. And instead, what I would do is I would start with these blue tenths here, and I would say, okay, I just want 2/10 of each of those, 2/10, 2/10, 2/10. So there's 2/10 of a group of 4/10 in that same space. And then once we identify that, we still have to put it all together and say, what part of a whole is this? And to answer that question, we noticed that there were 1, 2, 3, 4, 5, 6, 7, 8 pieces out of 10 by 10 out of 100. And so there's my 800ths, which we can put as a decimal. And remember, when we look at these, we want to avoid the slang 0.08, or even worse, 0.08. That's a 0, not an O. We want to say it as 800ths. Super important. And welcome, Evan.
Hello.
Right, so that's the basic example there. Let's go to our toys. So the toys are linked in the activity. And in the activity, I demonstrate a much more complicated problem. We'll do one like this in just a minute, but a little more complicated. Down here, I link out to the number pieces app. I think that's this one below. And I just want a new one, so let's reset that. I want to clear all. I wonder if that actually erased it for real. I'm curious. Open, incognito. No, it's still there, good. All right, so there's my version that you could get to if you want. And there's, I think I remember now, at the top, I put a link to the blank app up there too. And again, at the bottom left, I recommended switching to the colored version here. And for most of the problems we do, we're going to say this piece right here, the flat is our one whole. And again, I like this colored version because if I take the flat and I break it up into pieces with the break into pieces, it breaks them into greens, and the greens are longs. And so that's one solid long, but I could always break that into the individual yellows. Do you want to clear? Yes, I do want to clear. Okay, so let's look at a more interesting problem. I don't want to do exactly one of these here. How about, yeah. Let's take a look at 2.3 times 1.5. What does this mean right here? So we're going to illustrate and explain this. And this is a lot like 23 times 15, which we did back in Math 211. I'm going to choose to use the area model here. And then what I'm going to do is I'm going to compare this to the expanded algorithm and the standard algorithm for multiplying decimals. So area model for multiplication, as far as my decimals go, we're going to say 1 flat is 1 whole area. And that's the key that's going to guide our work here. So now I'm going to scoot on over to my toys, and I'll also draw this by hand. Actually, I have a question from you. Do you want to see me draw it first by hand or use the toys first? Anybody have a suggestion out there? Which do you find harder?
I guess draw it.
Yeah, I think that's probably harder. And if you don't have graph paper, you have to draw it out. And so at home, I usually whip out a ruler. If you don't have a ruler at home, here's the solution to that. I'm gonna, let's see, to turn off the share. And so you can see my, if you don't have graph paper and you can't find a ruler, my hope is that you have some lined paper around. And so lined paper becomes a ruler. You could just fold it in half lengthwise. And now I have a ruler. And the ruler is measured in the spaces between these lines here. And so I can use that as a ruler. So 10 of those would be like 1 hole, for example, for my ruler. Or maybe you find 10 of those too wide. Then what you can just do is grab a pencil and then just cut them in half. And so the distance from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that right there could be 1 whole length split into 10 pieces, and you just made, right, your own ruler there. So it is important that you do accurate drawings, and to practice doing them, you either need a ruler or graph paper. All right, so let's switch back to the screen. And I'm going to use the graph paper that I have here. Here we go. So then I need to measure out an area that's 2 3/10 by 1 5/10. So I'm going to say for mine, the base is going to be 2 3/10, and the height is going to be 1 5/10. And so then draw that out to the best of your ability. So let's see, we'll start, say, over here-ish. I think that gives me enough room. I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, 10 is in a nice spot. And then let's see, I need to go 5 higher. So 1, 2, 3, 4, 5. I think that goes there. And then the other way, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 to there. Mark. And then 5, 5. I think I got that right. And then 3 more. I think it goes to there. And we'll double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's definitely my 1. And then 1, 2, 3, 4, 5. So there's my 1.5 height. And this way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, so there's my 1 right there. 1, 2, 3, 4, 5. And sometimes I mark off my 5s in case I lose count. 6, 7, 8, 9, 10. There's nothing wrong with marking off every one. So there's 1, there's 2. So then right here would be 2.3. So in order to make your area work, you have to accurately know how far is 2 3/10, how far is 1 5/10. So first stage one is just saying, okay, oops, here's my rectangle. Let's make that neater. All right, so my answer lives in there. So now I just got to find the answer in here. So the second stage that I showed in the activity is say, okay, mark the decimal point in the picture. Well, 2 and then 0.3, marking the decimal point would just mean drawing that line right there. So here's my holes on this side, here's my fractions on that side. And then over here is 1.5, so there's my 1 below and my 0.5 above. Next thing, we want to turn this into base 10 blocks. So my next stage is to then draw the divisions between the ones, so I can see one hole, and then draw in your tenths. So I want to draw my tenths that way, and my tenths that way, and my tenths this way. So everywhere there needs to be a tenth. So we want to have the holes drawn out, we want to have all the tenths drawn out. So this is like the third stage of my drawing. My first stage is measure out your base, measure out your height, draw the rectangle. Second stage, separate the decimals from the whole numbers. Third stage, draw out the tenths and the other holes if there are other holes. So now we're ready to answer this. I'm going to throw in a new color just for fun, a slightly different color separating the decimals. Because right away I can see some important information here. So I'm going to start scribbling on this. So right away, I see 2 holes right here. Okay. Up here, I see 5/10 and another 5/10. So up here, I see 10/10. That's 10/10. All right, think about that. 10/10. Divide by 10, shift that decimal place once. Oops. Not good. 1 hole. So there's a hole hiding up here, and I'll have to do a trade in a minute to get to it. Over here, I see 1 2 3/10. And up here, I see 1 2 3 by 5. 3 times 5 is 15. There's 15 what right here in the corner? 15 tenths, 15 pieces, 15
Ones?
not ones. These are the ones over here.
Oh, hundreds.
Hundreds, there we go, yeah. So over here is 1500s, which I'm just gonna write in decimal form, right? The proper way to read that is 1500s, not 0.15, right? That's slang. So I can see the answer sitting right here. Because of the way we write decimals, writing 10/10, where you put the decimal point in the right spot, right? Isn't that the tenths position right there? And if I ignore the decimal for a second, there are 10 of them. So 10/10 is a whole. So I'm just going to make a note here that with these 10/10 here, I'm going to trade those 10/10 for 1 whole. And I can also do this right here. I can do a trade of 1 2 3 4 5 6 7 8 9. I could trade 10 of these hundredths. Remember doing this back in Math 211? But we were trading 1s for 10s and 10s for hundreds. Trade 10 hundredths for 1/10. And that kind of happens naturally just in the way we write these numbers. Again, avoid slang. 0.15, there are 15 things here. Those things are hundredths. That's 15 hundredths. That's the way we're supposed to read it. So my answer is living all right there. I have 2 holes. I have 10/10. I have 3/10. And I have 15 hundredths. And we already know from addition to line up the decimal point. So that's 5 hundredths, 4/10 altogether, and 3 holes. So the answer should be 3 and 45 hundredths. Again, avoid slang. Don't call it 3.45, 3 and 45 hundredths. Other ways to view this, I'm gonna show an expanded. So this is kind of an expanded multiplication there. I'm just going to show that in a couple of different ways. One way, and you'll see this in kids' textbooks, is to write 2 and 3/10 like that, 1 and 5/10 like that. And then often what they'll do is they'll do the whole numbers first. So 2, we're multiplying, right? So 2 groups of 1 is 2. And then 2 groups of 0.5 is going to give us 1 or 10/10. And then, so I did the 2 times each of these. Next, I do the 3/10. 3/10 times 1 is just 3/10. And then 3/10 times 5/10, hopefully we realize that that is 15/100. And then pulling that together, we're going to get 2 and 13/10, or 1 and 3/10, and 15/100. And at this point, it's kind of nice to stack them, but I think we can handle this. 2 and 1 is 3. 3/10 and 1/10 is 4/10, and then there's the 5/10. So that's just a slightly different variation on the expanded algorithm. And then let's show the standard algorithm. And with the standard algorithm, we really don't worry about the decimal point, and I'll talk more about that in a minute. We kind of ignore the decimal point and just say, hey, 3 times 5 is 15, and we write the 5 there and the 1 there. And then 5 times 2 is 10, plus 1 is 11. So I'm going to run out of room quickly here. And then we skip a place. 1 times 3 is 3. 1 times 2 is 2. And then we add things up. 2 plus 1 is 3. 1 plus 3 is 4, and 5 plus 0 is 5. And then the question is, where does the decimal go? And because we took tenths times tenths, we end up with 100ths. And so it has to go there. And so a reminder, if we take tenths times tenths, which is tenths times tenths, that is 100ths. So this is the standard algorithm. This is a variation on the expanded algorithm, and this green one's another variation on the expanded algorithm. So then what I'm hoping is for each of the problems that I gave you in the activity, you're going to do a couple of things. You're going to, up front, for all of them, state multiplication is area, area is base times height, a flat is one whole area, and then you're going to show that area. And then from that area, you're going to pull the answer out, trading if necessary. And trading isn't always necessary. Here it was. Here I had to trade tenths for hundredths. And that happened in a couple of places in my algorithms. So here, there was a jump to a new place. Actually, let's use a different color. So that was a jump of tenths to hundredths, or tenths to a whole, right there. And that happened again right here, where I had 2 groups of 0.5. That's the same one I have right here. So each of those is a carry because I ended up from the tenths to the wholes. So I switched places. And that carry is a trade with the blocks. And then there was also the jump right here, where we had hundredths, 15 of them. 10 hundredths is a tenth. And so there's this natural jump to that place value there. That also occurs here. And that also occurred here. All right. So let's see, back here. So here again, oh, I was going to do the toys, yeah. So let's do that same thing here. So in these toys, you get a couple things to work with. One, you got the blocks. I recommend the colored version of the blocks than the non-colored. At the bottom, you have a text typing tool you can work with, and you can try to draw with your mouse, or if you have a stylus tablet, although this doesn't recognize my stylus tablet for some reason. So here I would just start off by putting some text on the page that just shows the problem, 2.3 times 1.5. So put a little initial information about the problem somewhere, usually near the top. And then one flat is one whole area. So that kind of gets me set up, and I can put that somewhere and it adjusts a little bit, and you can blow it up if you want. I think that's already the big, oh, it gets bigger, yeah, a lot bigger. So then I want to try and build that. And for some of these problems, I got to kind of draw it out on paper first. And sometimes I can just come over here and start playing. So let's see, for sure, I got to get 1.5 tall, 1 1/10, 1 2/10, 3, 4, oops, I missed 1, 5. All right, so there's 1 5/10 tall, and then I got to get my base going. So 1, 2, and then I got to get my 1, 2. I'm gonna get them close enough so they snap together. There we go. 3. So I kind of get the outline along the base here. I'm showing 1 2/10, and for the height, sorry, 2 3/10, and for the height, I've got my 1 5/10. And then I just have to fill. And I can just copy some of these. If you click one and then shift click the others, it'll group them together. So then you can make a copy. I don't know if that's any easier than dragging 5 more onto the screen. And then I want 1, 2, 3 at a time. Oops. Let's move those over and copy. It's too many. So get your grid set up. So when you make this, it's got to make a rectangle. And the rectangle has to have the dimensions of the numbers you were given, because it's an area. Area is a rectangle. At least the easiest version of area is a rectangle. Next quarter, we'll look at more complicated areas than a rectangle. All right, so I just want to make a note here that I have my base, 2.3, that label in, and I'll put a height label too. All right, so there's my labels for the base and the height. Then somehow I got to pull the answer out of this, and there's lots of ways to go out about doing that. One complicated thing about doing it on the screen here is, I go back to my notebook, it's really easy to write this on a piece of paper and take a picture of it, but making that happen in a word processor is a lot trickier because you'd have to hit the space bar a whole bunch of times to get stuff in the right spot, and that's a kind of a pain in the butt, but I'm going to try it here anyway. So although it's nice to do things on a computer sometimes because they look pretty, sometimes it's such a pain in the butt. I don't know if a bunch of you did the test on a word processor, and I was wondering if on some of those problems it was, making the word processor do what you wanted was sometimes a pain in the butt. All right, so we need the answer here. So I think I'm going to grab the drawing tool and draw, what color? How about blue might look okay on top of this. So maybe over here I could just label stuff like this right here is 2 holes. This right here, kind of like I did before, is 10/10. And if you think that looks sketchy there, you could write out 10/10 instead. Ooh, whoa, how did I do that? All right, there we go. I guess I need to use the eraser. So if that was freaking you out, could just type in there. Which is what those green things are, right? There's 10 of them and they're tenths if this red one's a whole. Down here, let's go back to the pen, I've got 3/10. Remember, we're trying not to use slang anymore. And up here I have 15, and those 15 are hundredths. So here's my 15 hundredths right there. And I'm going to attempt to do this, the expanded algorithm that we looked at last quarter with text. Wish me luck. Let's blow it up a little bit. Let's see, is that the big version? We'll find out. So let's see, I want to take 2.3 times 1.5. And so now you can see I need some spaces to line things up. And usually we put a bar underneath, so maybe that's my bar underneath. Okay, so if I take 5/10 times 3/10, what does that give me? That gives me 15/100. And then I want the decimal places to line up. Kind of lines up there. And then 5/10 times 2, that would be 10/10. Line it up, go. All right, so I dealt with the 5/10. Now I dealt with the 1. 1 times 3/10 is 3/10. So I'm going to get 3/10 in there. And then line up the decimal. So in this problem, writing it on paper feels easier than typing this in. And then what's next? Next I have 1 times 2, which is just 2. And line that up. Draw a bar and put it together. So let's see, 5/100 plus nothing is 5/100. 1/10 plus 3/10 is 4/10. And then 1 whole plus 2 wholes is 2. And slide it over to line up the decimal. I think my decimals line up. Let's see how this looks. Okay, so this right here is my version of the expanded algorithm. And I'll just go through it again with you pointing at the screen. Let's see, can I use the laser pointer here? I think. So first I want to take my 5/10 times 3/10, and that's 15/100 here. And then 5/10 times 2 is 1 whole, or 10/10. Done with 5/10. Move over. 1 times 3/10 is 3/10, and 1 times 2 is 2. And the whole time I'm lining up the decimal point because I know I want to add these up after, and I can only add like things. Tenths to tenths, hundreds to hundreds, ones to ones, and then we consolidate. So this is the expanded algorithm with decimals. So I guess I better label that.
Would your answer be 3.4, Gary? Or 3.5?
Yes, because I don't know how to add. 1 plus 2 is 3. Ah, help. Sorry, a sec here. There we go. Just label this and then fix that. Expanded algorithm. Yes, 1 plus 2 is 3, not 2. Thank you so much. All right, cool. That looks better. So that's, you know, the similar thing I did on paper, but with these things right here. And, you know, so this was nice in setting up the picture with these toys because I didn't have to worry about drawing straight lines. On the other hand, drawing it on paper, it was way easier to write this kind of stuff out over here. It's way easier to draw that on paper than it is to have a computer do that by typing stuff. So you decide how you want to turn it in. Do you want to turn in pictures like this? Or you can do some combination, or do you want to use the app to do it? So you can go either way. All right, so what I would like to do next with you guys is have you guys break into groups of 2 and have one of you take control of that Number Pieces app. Go back here. And you can get to the Number Pieces app if you don't already have a bookmark at the top of activity 6.2b. And so one of you in the group is going to take control of the app, trying to do something like this, but for the first problem here, 2.4 times 1.2. Because I just want you guys to get together and agree about the sequence of events that happens in order to turn the area model into an answer. How do the numbers 2 and 4/10 and 1 and 2/10 turn into an answer using base 10 blocks? So just kind of repeating what I did here. And then we'll just look at the multiplication.